Welcome to Math Cafe. Enjoy math sip by sip. This is the second part of the chapter, relations and functions. And in this part, we are dealing with the domain and range. How do we find the domain and range of the given function? What is a function? That's our first point to know. What is the domain and range, and how do we find the domain and range of the given function? Let us just start from the last topic what we have discussed, that the relations. Let us consider two sets A and B as 1, 2, 3, 5 and B 4, 6, 9, and I have a relation defined as x, y such that the difference of x and y is an odd number. X belongs to A and y belongs to B. Let us write the relation in roster. See, 1 minus 4 is an odd, so clearly you can add 1, 4 and then 1, 6. 1 minus 9 is even, so you can't take it. If you take it 2, 4, 2, 6, it will not work. Then it comes to 9. And if you consider 3, 3, 4, it is 1, and 3, 6, again 3, that also a possible value. But again 3, 9, 3 minus 9 is 6, that you cannot use it. Then if you start with 5, 5, 4, 5 minus 4 is 1, and 5 minus 6, again it is odd, and 5 minus 9 is what? Not a odd number. So these are the elements of this relation. Now what could be a function? A function means it is a special kind of relation such that every element in the first set should have a unique image in the second set. Whatever element you take from the first set, say 1, 2, 3, 5, and here you have the second set B as 4, 6, 9. Every element in the first set have exactly one image in the second set. Such a relationship is called a function. If you notice here, you can see that the element 1 has two different images, so it is not a function. Simple thing. Its classic example for a function is your student's life. You cannot study in two different schools at a time because you can study only in one recognized school at a time. Usually if it is a function from A to B, we will written as f from A to B. X is an element from A and y is an element in B. We usually write as y equal to f of x. Y is a function of x. X is the input, or in other terms, function is always an operator. Whatever you are inputting, that is x, and your corresponding output will be the y value. X is the independent variable, and whereas y will be the dependent variable which comes in relation with the x input. A function is simply a special type of relation from a set A to a B such that every element in first set A has a unique image in the second set B. The first elements of the set is called domain, and the second set of elements will call it as range, and the whole set B as codomain, as usual what we have seen before. We are going to see how to find the domain and range. Now for a function, the thing is that as it is an operator, what we are checking is that first of all, when you talk about domain, which and all values I can input into a functional machine or a functional operator. That is what is our first question. That will solve the purpose of domain. Which are the possible values I can input for x? And again, you know that we are considering always a real valued function. All the real numbers we are considering. You cannot check each and every element in the real numbers and see whether it is defined or not. What we will check, some simple cases where the particular function is not defined. So you need to remember just some small cases. One is simple idea, what is 1 by 0? Or if denominator becomes 0, can you calculate that expression? Can you find that value? Denominator, if 0 means you can't find that value. So you need to exclude this case wherever the denominator is becoming 0 to get the domain. So the first point is wherever denominator becoming 0, that case you need to exclude. Then we have another case, second case will be there. Can we find square root of all the numbers? If I have square root of -2, what is the value? And you know that you have learned you cannot find the square root of a negative number as it will not give you a real number. If anything comes under the square root, whatever expression comes under the square root, you need to make it sure this expression, for example, if you consider an x, this you need to make it sure it is always positive. So the first case, denominator cannot be 0, and the second case, under the root number must be always positive. Now if in case if both comes together like this 1 by root x, we need to consider x must be greater than 0. These are the three cases you need to remember to get the domain very well. And once you got the domain, range will be automatically will follow with the input values. So we are checking about what are the possible values for which the given function is defined. Let us take some simple examples. Maybe the first one, I'm taking it as f of x is equal to x. Clearly, you can easily say no denominator and no root, right? No denominator and no root. So straight away, the domain will be all the real numbers and the range also will be all the real numbers. Clearly, there is no restrictions as a square root or denominator. That is the reason every real number will be the domain and as well as the range. As the domain is real numbers input, output as the same thing. So it is always the real numbers. Let us consider another one as f of x is equal to modulus of x. What will be the domain and range? Again here there is no square root and there is no denominator. So the domain will be what? All the real numbers. Now for the range, what will be the value when you are inputting into a operation as mod x? And you know that when you take the modulus of x or absolute value of x, you always get positive as the answer. Clearly we can say for every x, this mod x is always positive. Therefore, the range will be all the values from 0 to infinity or positive real numbers. Let us see something new now. Maybe I have the function f of x is equal to 1 by x plus 2. What will be the domain and range? These are the most important type questions. Again, clearly you can see here you have a denominator here. That's what we said. Denominator must be what? Always not equal to 0. One method is that you can just take the denominator and equate with 0. So this will give you x is equal to negative 2. Now you know that this is the value for which the denominator is becoming 0. So what you need to do? Exclude that value which makes the denominator 0. So your domain will be everything except this negative 2. You need to strike out that negative 2. Domain will be all the real numbers except negative 2. So the idea is that any denominator comes, equate to the 0 and remove that. That will be your domain always. Now range, you know that f of x defined when r is not equal to minus 2. And range means, as I said, you have the input is x and your output is what? Y. You know the function is given as what? Y equal to 1 by x plus 2. Now what we are checking is that corresponding to the input x, what could be the output? For that you need the value of y here. So you rewrite it as x plus 2 equal to 1 by y or x is equal to 1 by y plus 2. This expression says you are looking for the y values for which the function is defined. Again you have a denominator. From here itself you can say, or you can write 1 plus 2y by y. Denominator comes as a y and we know that denominator cannot be 0. You exclude the case where denominator becomes 0 and this becomes 0 whenever it is y equal to what? 0. So what will be our range? The range will be what? All the real numbers except 0. The procedure is that you write it as equal to y, rewrite the expression as x in terms of y only without any x. No x should be in this expression. Then if you have a denominator or a square root, apply the condition. Denominator means it cannot be 0 and square root means what? It should be positive. So the range will be r minus 0 and the domain we got it as what? R minus negative 2. Let us see one more question. F of x is equal to, this is x minus 2 by x minus 1. Again here denominator I am equating with the 0. X minus 1 equal to 0. That gives x is equal to 1. Therefore the domain is what? Everything except 1. Hope you got the idea. Denominator equate with the 0 and exclude that value from the whole real numbers. That is what is your domain and you have done. Now let us see the range. Again the same procedure. Whatever expression given, equate that with y and you rewrite this expression as x in terms of y only. I repeat, in terms of y only. That means you have to write x as some expression of only with y without any x. Cross multiplying xy minus y equal to x minus 2. And you are looking for the value of x. So collect all the x on one side, xy minus x. Shift the y to the other side. Minus y go that side, become positive y minus 2. Take x common, x into y minus 1 equal to y minus 2. X is equal to what? Y minus 2 by y minus 1. Again, you have a denominator, and that says what? You have to make denominator not equal to 0. That means y is not equal to 1. Therefore, the range will be what? All the real numbers except 1. Basically, whether it is domain or range, whatever it comes, you need to understand that denominator cannot be 0. Any situation where denominator is becoming 0 must be excluded. That is what is your answer. So the range is r minus 1. Let us consider another example. F of x is equal to x square plus x plus 1 by x square minus 6x plus 8, and you need to find the domain. Range also can be calculated, but for the time being and for the school exams, and if you don't want, if you're trying to crack JE and all, you need to go for the range. I'm not showing that one now. Denominator should not be 0, so equate with the 0 and factorize it. The product is equal to 8 and sum is equal to negative 6, and you know the numbers are 4 and 2 with a negative sign. So this is x minus 4 into x minus 2, which will give you 0. Product is 8, that is why minus 4 and minus 2, 8, and minus 4 plus minus 2 is minus 6. Now this gives you x is minus 4 equal to 0 or x minus 2 equal to 0. X is equal to 4 or x is equal to. Now there are two numbers which make the denominator 0. That is, one is 4 and other is 2. What it says? Both 4 and 2 must be excluded from the real number. So the domain will be what? All the real numbers except 4 and 2. That is our answer. Let us consider the next example. F of x is equal to root of x minus 2, and the domain and range you need to find. As I said, you cannot find root of negative numbers. That says clearly the number under the root must be always greater than 0. So this f of x will be defined only when x minus 2 is greater than or equal to 0. That says x must be greater than or equal to 2. Therefore, your domain will be all the values which are more than 2. Now for the range, you have different methods, and then I'm showing a simple method which will be helping you to get the answer. Range means we know that whatever your input, corresponding outputs are the range. For that, this function is defined if x is greater than or equal to 2. From this condition, I am going to create the original function, that is root of x minus 2. This gives you x minus 2 is greater than or equal to 0. You are finding the root, so that also will be greater than 0. You got it? The input is x is greater than or equal to 2. From the condition of the input, I am creating the output value, that is root x minus 2. When x greater than or equal to 2, clearly you are bringing the 2 to the left side. That also become positive. And if you are finding the root of a positive number, that gives you always a positive value. The range is what? F of x is greater than or equal to 0, or range will be what? All the values which are more than 0. The domain always positive value under the root. That I made it sure, so I got it as 2 to infinity. For range, I am using the condition for which the function is defined. Now let us consider the most important question from this chapter. F of x is equal to root of 9 minus x square, and we need to get the domain and range. You know that 9 minus x square must be greater than or equal to 0. That gives 9 is greater than or equal to x square, and I am keeping x square is smaller than or equal to 9. Now if x square is smaller than or equal to 9, what could be the values? X square can be written as less than or equal to plus or minus 3 square. This is one condition you need to remember. Whenever you have a squared inequality, the rule will be whenever x square is less than or equal to plus or minus 3 square, this gives you always x less than or equal to 3, or x could be greater than or equal to negative 3. The way you need to remember is this way: inequality with the same inequality to the positive value, and reverse inequality with the negative value. There are so many ways are there to prove this one. As the time being, you can just remember that one. People will say x less than or equal to 3 or x less than or equal to minus 3. If you take x less than or equal to minus 3, you choose x is equal to minus 4, then you will realize you are wrong, because negative 4 square will be 16. 9 minus 16 is going to be negative, so it will not work. What you need to remember, if you are solving a squared inequality, the solution will be always same sign with the positive value, reverse sign with the negative value. This you need to remember to get the answer. This says x is smaller than or equal to 3 and x greater than or equal to 3. Again, to make it clear, you can use just this number line. This says x greater than or equal to minus 3, and this says what, x less than or equal to, it lies between -3 and 3, therefore the domain will be what, -3 to 3, that is our domain. Let us look into the range for the same question. We have taken as f of x is equal to root of 9 minus x square, and we got it as this f of x is defined if -3 less than or equal to x less than or equal to. Again, there are many approaches are there to get the range. I'm going in this way. I have the value of x lies between -3 and 3, and my objective is to get 9 minus x square. For that, first thing, I am squaring every term. So I will get x square less than or equal to 9, and this also 9, but that obviously that will not work because 9 to 9 there will be nothing is left. Here you should use little bit our common sense as like this way. What could be the least possible value of a square number? What is the minimum value of a square number can you choose? When you square it is always a positive value, and the least value is always what, 0. This idea should be clear, and you need to question it, why I have used 0. Why do I take 0? Because the square number will be always positive, and the least possible value it could take on it as 0. Now I got already x square term, but I am looking for a 9 minus x square. How do I get a negative x square? Multiplying everything with a negative sign. Multiplying everything with a negative sign, that will give me 0, and this is negative x square and negative 9. Now when you multiply with the negative sign, what happens to the inequality? And you know that 3 is greater than 2, and if you multiply with minus number, it will become -3 and -2. Obviously -3 is less than negative. Hope you know that idea very well. When you multiply, the inequality will be reversed. So I am writing 0 greater than or equal to minus x square greater than or equal to negative 9. And I am looking for a 9 minus x square, so I am adding a 9 everywhere. That gives 9 greater than or equal to 9 minus x square and 9 minus 9. I am adding a 9 everywhere. So this is 9 greater than or equal to 9 minus x square greater than or equal to 0. Just rewriting in the order of small to big, 0 less than or equal to 9 minus x square less than or equal to 9. Take the root, 0 less than or equal to root 9 minus x square less than or equal to 3. So you got f of x is lies between 0 and 3, or y lies between 0 and 3. So what is the range? 0 to 3. So that is what is the answer. The range is equal to 0 to 3. Let us look into one more example the same way. F of x is equal to root of 16 minus x square. And you know that 16 minus x square must be greater than or equal to 0, as it is under the root. This is 16 greater than or equal to x square, or x square is less than or equal to 16. 16 will be 4 square, you know that. So x will be less than or equal to 4, or x will be greater than or equal to negative 4. Same inequality with the positive value and reverse inequality with the negative value. If you check, this is minus 4 and 4 greater than or equal to minus 4 and smaller than or equal to 4. The domain will be what? Minus 4 to 4. Now let us see the range. This f of x is defined whenever x lies between minus 4 and 4. Again, our target is now 16 minus x square root. I need to get it. So how do I get it? Going the same like the previous one, I am squaring first. X square less than or equal to 16, and you know that now very clearly the square number is always having a least value 0. Now you multiply everything with a negative, so 0 greater than or equal to minus x square greater than or equal to minus 16. Now you add a 16 everywhere. 16 greater than or equal to 16 minus x square greater than or equal to 16 minus 16. 16 greater than or equal to 16 minus x square greater than or equal to 0. Take the root. 4 greater than or equal to 16 minus x square greater than or equal to 0, or this is 0 less than or equal to, this is same as our function y less than or equal to 4. Therefore range will be 0 to 4. So that is the range of the function, and everywhere you have alternative methods are there. I have shown one of the way. Hope you have enjoyed this video, and hope you understood how to find the domain and range. To find the domain and range, we are always looking at the input value, that is the domain, and output value will be y. Thank you for watching Math Cafe. Please like, comment and share, and we'll back with more typical questions of domain and range in the next session.